All right, once again, we are looking at finding confidence intervals based on sample survey data. We're told that a student polls her school to determine whether students in the school district are for or against the new legislation regarding school uniforms. She surveys 600 students and finds that 480 are against the new legislation. And this is specifically for Part A. We're asked to compute a 90% confidence interval for the true percentage of students who are against the new legislation and interpret the confidence interval. So what do we have given in our information within the problem itself? We want to know, first off, with Part A, it's 90% confidence. We know our error bound on the proportion equals the z-score times the square root of p, which is the proportion of successes, q, which is the complement of that, divided by n. With 90% confidence, our z-score, that should be one of the ones that we know by heart. That's going to be 1.645 times the square root of, we have 480 out of the 600 are against. So that's our P, our proportion. The complement of that, 480 to 600, is 120 students, 120 students out of 600. So that's our Q. Our sample size we're given is 600. So that's approximately 0.0269, which gives us a confidence interval, adding and subtracting from our 480 out of 600, which is actually exactly 80%. That's going to give us a confidence interval of 0.8 minus 0.0269, which is 0.7731. And then the 480 divided by 600, which again is 0.8. So 0.8 plus 0.0269 is just going to be 0.8269. And then what that means in context, interpreting the confidence interval, that means that we can be 90% confident that the true proportion of students in the school against the new legislation regarding school uniforms is between 77% and 83%, rounding to the nearest percentage. That's what that means interpreting the confidence interval. We're 90% confident that the proportion of students in the school that are against the school uniform legislation is between 77% and 83%. Now, in the next part of the problem, we're told in a sample of 300 students, 68% said they own an iPod and a smartphone. We're asked to compute a 97% confidence interval for the true percentage of students who own an iPod and a smartphone. Now, this isn't one of the ones that we're technically meant to have memorized. You can find it in a couple ways. You can go to a z-score chart, but in that instance, you need to remember that with a confidence level of 97, we need to add half of that tail onto it as well. If you go back to example 10.3.2, when they found z alpha divided by 2, it was the 10%, 1 minus the 90% confidence, which is 10%, divided by 2 was 0.05. So you would add that to your percentage when you look up the z-score chart. So you'd be looking at 1 minus 0.97 is going to be 0.985. When you look up the z-score for that percentage, it's going to be 2.17. So our z-score, z alpha divided by 2 equals 2.17. Now you could also use your calculator if it's available and just go to the distribution, DISTR, which is above the VARS button, and go to inverse norm and then just put in the 0.985. It's going to give you the 2.17. Inverse norm gives you a z-score based on a probability or percentage. Same thing as looking it up in a chart. It might actually give you one that's a little bit different. It might be like 2.17000 something. But for all intents and purposes, it's the same score, the same z-score. So we also know that n equals 300. P we're given as 0.68. Q we're given as 0.32. So using the same formula, error bound on the proportion equals, we said the z-score is 2.17. That is times the square root of 0.68 times 0.32 divided by 300, which is approximately 0.0584. So then our confidence interval is going to equal the 0.68 minus 0.0584. And the 0.68, our P proportion, plus 0.0584. And when we put that into our calculators or do it manually, we're going to end up with a confidence interval of approximately 0.6216 to 0.7384. And in context, what that means is the true percentage of students who own an iPod and a smartphone. We are 97% confident that it's between 62.16% and 73.84%. Now we should also know we can check this using our calculators. Let's bring in the calculator here real quick just to check this second solution. So we would go to stat, tests, go down to the one proportion z interval, which is the 11th choice. It's under A. The 68% of 300 is 204, so we would enter in 204. You could also put in here 0.68 times 300. Hit enter, it will give you the 204. Our sample size is 300. Confidence level is 97. Hit calculate, and we do verify we get 0.6216 and 0.7384. You could also check your solution to part A as well. I just wanted to make sure that you remembered how to do this on your calculator. For assignments, wouldn't be using it for an exam, but also to check solutions as you work homework exercises, written assignments, exercises, and quizzes as well.